good afternoon, everybody. Welcome to ERF 26 Annual Conference, session on natural resource, environment, and climate change. We have today 4 presenters. The first is Dr. Amira Elayouty and a paper by Dr. Amira Elayouty and Hala Abou-Ali, exploring the relationship between electricity consumption and drivers of climate change, a functional data analysis. The second paper is by Dr. Dina Kassab, and it is titled Agree to Disagree, Making Sense of Vagueness in International Environmental Agreements. The third paper is by James Luckmann, and the title is Redistributing Water Rights Between the West Bank and Israel, More Than a Zero-Sum Game. The fourth paper is by Insaf Guedidi, and the title is Carbon Dioxide Emissions, Environmental Provisions, and Global Value Chain, the Middle East and North Africa in Global Context. Now, every speaker has 15 minutes to present. This will be followed by 15 minutes of discussion comments and opening the floor to the audience to ask questions. Now, for the audience to ask questions, you can either click down on the question and answer spot here, or raise your hand as a participant, and we will give you the floor to ask your question. Now, I will just give a brief introduction of each speaker, and then we will start with Dr. Amira Elayouty. So, Dr. Amira Elayouty is currently a lecturer of statistics at the University of Glasgow and an assistant professor of statistics at the Faculty of Economics and Political Science, Cairo University. Amira holds a bachelor and an MS degree in statistics from the Faculty of Economics and Political Science, Cairo University, and a PhD in statistics from the University of Glasgow, United Kingdom. Her research interests include spatio-temporal models, non-parametric regression, additive models, and functional data analysis, with a particular focus on high frequency and big environmental and socioeconomic data and statistics. Our second presenter is Dina Kassab, is assistant professor at the Faculty of Economics and Political Science, Cairo University, and a research associate at the Economic Research Forum. She received her PhD from University of Paris, Pantin, Sorbonne, and her MA in Theoretical and Empirical Economics from Paris School of Economics and Paris 1. Her research interests include game and incentive theory and their applications to political economy, monetary fiscal games, international environmental agreements, and corporate social responsibility. Our third speaker is Jonas Luckmann. Dr. Luckmann is lecturer and researcher at the International Agricultural Trade and Development Group at Humboldt University of Berlin. His main research interests focus on economic modeling of the water sector using simulation models. Our fourth speaker is Insaf Guedidi, is a PhD candidate in economic sciences at the Higher School of Economic and Commercial Sciences of Tunis, under a joint supervision arrangement with the University of Paris 1, Pantin, Sorbonne. She is a World Trade Organization Chair Junior Fellow at the University of Tunis. She obtained a BA in Business Analytics and Finance from Tunis Business School. She holds an MS degree in Economics and Business Intelligence from Higher Institute of Management of Tunis. Her research interests include international trade, global value chains, trade agreements, and international economics. So welcome our speakers, and let's start with Dr. Amira Elayouty and her paper exploring the relationship between electricity consumption and drivers of climate change, a functional data analysis approach. Go ahead, Dina, you have 15 minutes. Sorry, Amira.
Yeah, you can hear me now?
Yes.
Okay. So good afternoon, everyone. Thank you very much for really organizing this session in this hard time. And thank you, Abir, for in your introduction. So it's my pleasure today to shortly present this paper in collaboration with Hala Abou-Ali on assessing how the impacts of electricity on CO2 emissions have changed over time using functional data analysis. So the changes in global annual average temperature anomaly shows that the temperature have risen up with almost 1 degree Celsius over the last decade relative to the pre-industrial period. This small increase in temperature on the long term can cause devastating environmental and economic crises and have impacts on development and human welfare. And that's why the UN have been urgently calling for all countries, without any exceptions, to undertake appropriate policies and measures to mitigate the impacts of climate change, and to trying to limit the change or the rise in temperature to below 1.5 degrees Celsius by 2028. The largest human influence on climate change was attributed to the greenhouse gases emissions, with over 90% of the impacts from carbon dioxide, which stems from the burning of fossil fuels. And that's why electricity has been considered the primary source for CO2 emissions. The CO2 emissions have been substantially increasing over the years since the first industrial revolution, but not just increasing, they are increasing at an increasing rate simultaneous with more development and energy production going on, which even stimulate more concern about accelerated global warming. And that's why it's very important to try to understand how the electricity and economic growth contributed to the increase in CO2 emissions, and how these impacts have evolved over time. So for this paper, we have annual data from the World Bank on the annual carbon dioxide and on the carbon dioxide emissions and electricity consumption per capita from 1975 to 2014, in addition to per capita GDP for over 100 countries, which are displayed here by the income groups. Unfortunately, these gray countries were not included in the analysis because they had large amounts of missing data, and it was impossible to perform the analysis using these data. So the main goals of the papers were to assess the differences between the countries in terms of the trends or the long-term trends of CO2 emissions and electricity consumption, then evaluate whether the differences in the trends of CO2 emissions are, whether these differences are significant across the different income groups, and finally to investigate how the impacts of electricity and economic growth on CO2 emissions has evolved over time, and how these relationships have changed, in particular in the MENA region over this period of study. So one useful approach for tackling these objectives, and that recently has proven to be quite useful for analyzing and extracting patterns from longitudinal or time series data for a large number of observations, is functional data analysis. So in functional data analysis, the data we deal with are no longer discrete data points, but the data are viewed as functions, which are denoted by XIT. So for example, here for each country, we observe time series of yearly data on the per capita, for example, on the per capita CO2 emissions. And in functional data analysis, the objective is to try and transform these discretely observed time series into continuous functions over time, using flexible regression approaches, or what we call smoothing techniques. So we do this for all the countries that we have. So that's just a visualization of what we do. So what we have now, instead of having these discretely observed time points for the CO2 emissions, we are going to use some flexible regression methods to trying to filter the noise and achieve some continuous function that describe the behavior of the variable over time, no matter the behavior, no matter how complex the behavior of the variable over time is. So now we are going to focus on these functions and trying to analyze these functions as our observational unit. So for each country now, we will have a profile of CO2 emissions, and we can do the same for electricity consumption as well. And so we will have for each country a curve for the CO2 emission and a corresponding curve as well for the electricity per capita. So all the multivariate statistical methods that we know have been extended in functional data analysis. So here we use the functional principal component analysis, which I'm going to give a brief just in a second, to identify the primary sources of variability responsible for the differences between the trends, responsible for the differences in the trends of CO2 emission and electricity between the countries, and then use regression and then use functional regression to explain how the average impact of electricity and economic growth on CO2 emission has evolved over time. So without getting into the fine details, functional principal components are extension or an analog of the standard principal component analysis, but in the functional space. And that's why we have here integration, and instead of a covariance matrix, we now have a covariance function, and instead of the principal component or the eigenvectors, we now have eigenfunctions. So the basic idea is still the same. We still want to decompose the covariance into a number of principal components that represent the major directions of variability in the data, such that these principal components are orthogonal, so that they carry independent information. So here, the top row shows the first two principal components for the CO2 emission, and the second row show the first two principal components for electricity. And from here we can see that the first principal component explains over 97% of the variability for both variables. And it's perhaps representing the deviations from the overall trend. Whereas the second principal component, which explain 2% of the variability, represent some contrast between what happens after some time here, close to 1990, and what happened before that period. The same interpretation applies for the electricity power consumption as well. So this means that any country that will have a positive score on the first principal component will have a higher CO2 emission than average. And a country that has a positive score here on the second principal component will have higher CO2 emission than average after 1990, but lower CO2 emission than average before 1990. So here I plotted the scores for the first principal component versus the scores for the second principal component for all the countries for both variables. And you can see here that all the high income group countries, which are in blue, are actually consuming more electricity, which is quite logical. But more interesting here is that the US and Japan, as well as most of the highly developed European countries, are managed to reduce their electricity consumption after 1990. And this has been translated also here in lower CO2 emissions after 1990 in these countries. But the Asian countries, including China, Singapore, and Malaysia, as well as the oil countries. Despite being in a high income group, they are still contributing with large amount of CO2 emissions. You can see
5 minutes, Amira.
Yes.
5 minutes.
Pardon?
5 minutes.
Oh, yes. Okay. And yeah. Yes, and so for the MENA region countries, you can see here that most of the MENA countries are contributing with large amounts of CO2 emissions, despite being in high income group or a middle income group. So here you can see the UAE or Egypt. Of course, this is with the exception of few countries that are also witnessing some political tensions, and of course they are not producing much electricity and CO2 emissions. Another goal was to assess how the impacts of electricity and GDP on CO2 emission evolve over time. And and here, because each of the variables is now a function, so also the regression coefficients are no longer scalars, but are rather function to represent how the relationship evolve over time. So the model that we fit here is called a concurrent model, which studies the relationship between the response at a specific time point to the covariate at the same point. So there is no lagged relationships here. So these were the estimated regression coefficients for the model, and you can see that there is evidence that the relationship hasn't been fixed over time and has been changing over time. And beta 1T, that's the coefficient representing the impact of electricity consumption on CO2 emission, is showing that this impact has been increasing up to some point here in 1990, and then started to decrease after this period, with more developed countries moving to renewables and efficient use of electricity to improve the environment quality. But this relationship rebounds again and started to slightly increase again over the last decade, which can be justified by not being able to catch up with increasing demand. Whereas for the influence or for the relationship between GDP and the CO2 emissions, you can here observe the inverted U shape, suggesting that the environment degradation and pollution begin to increase in early stages of economic growth, but then they tend to decrease with the realization of developed countries, which contribute most to the global CO2 emission, the importance of environment quality. And so they move more to the use of renewables and to shift from heavy industries to more developed manufacturing, to more advanced manufacturing. So if we fit the same model, but for just the MENA region countries, we find that the impact of electricity consumption on CO2 emission hasn't probably changed over time, but the influence of GDP was decreasing, then started to show some rise from the late 90s, simultaneous with many ongoing reforms in the region. However, the model has shown quite a lot of variability, especially in the recent years, and this can be justified by the large amount of discrepancies between these countries. So we have the Gulf countries, and also we have many developing countries. So and can also be justified with the political economy the political economy in the region. So in conclusion, the highly developed countries like USA, Canada, or Europe have managed to reduce their per capita emission over time since 1990, along with their economic growth, and still have to continue with relying more on renewables to be able to catch up with the high demand. However, the MENA region are still contributing with increasing per capita CO2 emissions and are quite behind in terms of SDG 13, and therefore they need to adopt firmer policies and measures and give more incentives to industries to adopt more energy efficient technologies. They also probably need to increase their capacity from the renewables, although these are quite abundant in the region, but they are also quite expensive. And that's why the governments of developing countries need to give more opportunities for entrepreneurship and new business to find solutions and to innovate for a cleaner environment. Thank you for your attention.
Thank you very much, Amira, for this very interesting presentation and for keeping up with the time. I'll follow now with my comments, and then we will open the floor for the audience to ask questions. Now, it's just that there are many studies on the Kuznets curve. So your contribution is doing this for the MENA region and using a new methodology.
Mm-hmm.
But you need to highlight this in the paper. This is not very clear in the paper. The second thing is that it would be helpful to provide statistics about the share of renewables in electricity generation worldwide and in the MENA region over time, and link this to carbon dioxide emissions. So my question is, why don't you have also the share of renewables as an explanatory variable in your regression? The third point is you have a very interesting result here, is that in Egypt, the influence of electric power generation on carbon dioxide emissions remains constant over time. And it's interesting to explain why this happens. The last comment I have is on the conclusion. You need to discuss more policy implications of your study. Now, would you like to comment on this, on my comment on my point?
Yeah. Thank you very much for your comments. They are really helpful. Actually, yes, maybe trying to think about adding something about the share of renewables. But here, the main issue was that this information, I think, wasn't available over the whole study period. So we can try to, I don't think this information was available from 1975 as for the whole study period. So maybe I can try to look what were the data available, because I think I have looked at this and there was one kind of limitation why I haven't used this, but I agree with you that this could be quite interesting to see the effect. So maybe we can, I can make the period shorter and try to see how this has evolved over time as well and how this has impacted the CO2 emissions. But it really depends on the data availability. So yeah, so I can have a look over this, and this could be quite interesting actually to look at. The second thing you have asked why the impact of why the impact of electricity on CO2 emission was almost fixed over time.
In Egypt, yes.
Yeah, I think that's not just in Egypt, is in all the MENA region countries. And I think this could be justified as there is, so that's the impact. So the impact is not changing over time. So it's still positive. So as energy is increasing, still the CO2 emissions are increasing, but the influence is not changing over time. And I'm assuming that this could be because most of the countries in the region are in an early stage of the Kuznets curve. And even the high income countries like, for example, Emirates or Saudi Arabia, they still didn't reach a stage where they have to give more, or they didn't invest more in using more efficient energy and electricity in their economies. So that's my justification for this.
Okay.
Yeah.
Okay, thank you so much for your comments. And now we open the floor for the audience to ask questions. Amira, you can read the questions and answers on your screen. So there's one question in the question and answer.
Yeah, it does. Yes, the first question is yes, the functional concurrent regression model, there are forms of forecasting.
Amira, can you read out the question because the participants can't see it? So read it please and then answer.
Okay, so the question is, does your functional concurrent regression model allow for forecasting? And the answer to this question is yes. There are forms of allowing for forecasting, but this, given that we of course know the what happens or what is happening on the covariates or the predictors. And the other thing is there another method to address the question of climate change following your approach? I don't. Is there another method to address the question of? I think, yes, there is quite a lot of work in terms of using functional data analysis. If that's the question is related to the method, or the approach here means the method. And I think, yes, there are quite a lot of work using functional data analysis on how to address the impacts on climate change and changes in temperature on the long run. So functional data analysis has been recently used a lot for big data and the analysis of big data. And that's why it's quite promising, and many people are now using it to address many environmental problems and issues.
Okay, thank you. There is a question by Shahir Zaki. Shahir, you have the floor.
Can we, for example, there is another question, sorry. Here I have, it says, can we, for example, use neural network? I think neural network is for clustering. So that's my answer to this question.
Okay, Shahir, you can go ahead.
Thank you, Amira, for the interesting presentation. I just have two suggestions. I was wondering whether it's important to take into consideration the difference between oil exporters and oil importers in the region, because I assume that having more oil exporting industries, they are more likely to pollute, and then perhaps you can introduce as one of your covariates either the share of fuel exports in total exports, or even more interestingly, but I don't know whether you will be able to find this variable or not, the share of FDI, in oil and fuel sectors, because most of the European and the American investments in the region operate in the oil sector. So I think taking into consideration these two variables will add to the analysis. And the second comment or suggestion, I don't know whether the analysis will hold on other type of emissions, not only CO2. So SO4 or other types of emissions. So thank you.
Okay, you can go ahead, Amira.
Yeah, thank you very much, Shahir, for your valuable suggestions. Yeah, I think I agree for the first one. I think this could be quite interesting to look at and trying to search for these data. and see how this would impact the model. For the second comment, yes, possibly, but I don't know if, again, I think it's also again about the data availability, because I think the World Bank was just publishing the CO2 emission, or the greenhouse gases emission, which actually the CO2 is contributing most to it. But I agree that this is also affecting, of course, many other pollutants and many other emissions, and it's worth to see the impacts on these as well.
Okay. Thank you, Amira. So there are no other questions. We will move to the second paper by Dina Kassab, making the sense of vagueness in international environmental agreements. So Dina, you have 15 minutes. Go ahead.
Thank you, Abir, for the presentation. And thank you, Amira, actually, for laying the ground for what I'm about to discuss. And if you'd allowed me, I would like to build on some of the findings you discussed in the paper. So actually, the paper is about environmental agreements at large. As you can see, after the Second World War, environmental agreements have increased in number, and they peaked by the end of the Cold War. However, the precision of this agreement has not progressed as much. For those who have studied environmental politics before, you can see that there has been two configurations of the world. In the previous world order, there was a small number of pivotal players. For instance, you had some European countries on the one hand and the US on the other. These were the main players, the top emitters, and environmental agreements were basically cross-Atlantic. Okay? So they had the high growth rates and hence the high emissions. However, they had high environmental preferences, meaning that there was a willingness to improve environmental quality. And these countries typically had large institutional capacity. And this is key in our analysis. Institutional capacity, you could simply think of it as the ease with which a country could implement a carbon tax, for instance. Okay? So if you implement a given policy, how easy would it be for the country to actually achieve its targets? This scene has evolved in the recent years. Let's take, for instance, the 2015 map. So you have the rise of power of China, and you have many other countries that become to be visible on the map that weren't before, the oil exporting countries, and so on. The problem with the new configuration is that you have heterogeneous players. They have different institutional capacity. It's not as easy to implement a carbon tax in France as it is in Afghanistan, for instance. So you have new players with different institutional capacities. Environmental preferences are also not quite certain, are quite varying among the key players, and they have varying power to destroy. Mainly, they are at different levels of economic growth. So this is the distribution of institutional capacity in the New World Order. So you see the highest emitters in the 2000s are not actually those with the highest institutional capacity. And this is probably bad news for environmental politics. This, I argue that this is why environmental agreements drafted in recently have been quite vague. For instance, in the Kyoto Protocol in the 1997, you had quite numerical targets, quite precise numerical targets for different countries. However, in the Paris Agreement in 2015, you have like broad guidelines, and countries have to think how they would interpret the guidelines of the agreement. So the main question here is whether there is necessarily a depth participation trade-off, meaning that to accommodate for those new emerging countries with low institutional capacity, do we have to draft agreements that are quite vague in order to increase participation, all while compromising the effectiveness of the agreement, or can we increase both? So by doing so, we contribute to two strands of the literature on the theoretical part. First, the literature on environmental agreements, And our main contribution here is that actually this is the first model, to my knowledge, that combines both membership and compliance, meaning that models in environmental agreements usually either deal with membership, assuming that the ratifiers would comply, or deal with compliance, assuming that they already participate. However, by introducing vagueness in the analysis, we make actually participation conditional on the extent to which they would be able to comply. According to, as to the abatement effort, we do not choose neither a uniform abatement effort nor a differentiated one, but rather assume that there is an implicit abatement effort that is optimal for everyone, and there is vagueness around how close we should be to that abatement effort. Another contribution to the literature is a contribution to the literature on the delegation in principal agent models. And this is actually quite interesting literature. For instance, take the example of the Supreme Court of Justice that gives a judicial opinion to the legislator. So it could craft the opinion in quite a vague manner, so that it gives the legislator a margin for maneuver to let him interpret the opinion as he pleases and exploit his policy expertise. And it also helps the Supreme Court of Justice to maintain some institutional prestige in case it's defied by the legislator. So it has policy concerns and image concerns. The cost of vagueness, clearly, is that it compromises actually the effectiveness of the commandment, the order. So when you give too much discretion to the agent, he could use it to advance his own interests and not achieve the desired outcome. This is what we replicate for the agreement, but we replicate it in the case of a principal multi-agent framework. So we construct the theoretical framework consists of a three-stage game. First, you have the negotiation phase, where you have different countries negotiating over the degree of vagueness of the agreement. Let's not go into the details, just a glimpse of it. So you have the moderator, the one who conciliates between the different opinions, and he chooses vagueness, the variable A, such that he gets as close as possible to the optimal abatement policy, but also as far as possible from public defiance or from non-compliance, visible non-compliance. So as he reduces decision, he makes non-compliance less visible, because then it would not be clear what actions actually were against the agreement and so forth. So there is a negotiation phase, which results in a given level of ambiguity. Given this level of ambiguity, each government decides on the policy that it deems to be optimal or to be consistent with the agreement provisions. And finally, the government presents it to its electoral constituency, let's say the median voter, who then decides whether to ratify it or not. So, without going into the details, the main assumption of our theoretical model is that we have heterogeneity in institutional capacity, meaning that not all countries can achieve the desired outcome by implementing the same policy. Okay? So it's more costly for countries with lower institutional capacity. The take-home message of the analysis and of the model is to answer the question: is there a depth participation trade-off? Meaning, do we have to draft vague agreements to increase participation, or can we do both? Can we have precise agreement and have everyone on board? The short answer is no. However, in the long run, in the future, the answer could be yes. Let's see why. The theoretical model results in two optimistic scenarios. First, there is the one in the old configuration. If you have mostly the top emitters in the high end of the distribution of institutional quality, meaning that they all have good institutions, in that case, you have a bandwagon effect. You have all countries participating because they expect all the others to participate. It's not costly to participate, actually. We're the top emitters, we have good institutions, we can all do this together. So they all participate. The avoiding rock bottom scenario is actually the one when things started to evolve a bit. It's when the top emitters started to become those with lower institutional capacity. Not too low, but quite low institutional capacity. In this case, the bandwagon effect is still found to be present. You still have countries with low institutional capacity that participate in precise agreement, okay? Even though their commitments in light of the agreement would be quite precise, just because they expect the neighboring countries in the distribution of institutional capacities to do so. A bandwagon effect in economics is when you expect your neighbors to do the same, so you all actually cooperate implicitly without agreeing, okay? The pessimistic scenario, however, you could call it the house of cards scenario, is when you have the top emitters of the very low institutional capacity. And this is the case where the debt participation dilemma occurs. This is the case where you can no longer have precise agreement with everyone on board. To achieve one,
Dina?
yes, okay. To achieve one, you have to sacrifice the other. So to test this empirically, we have 3 implications pertaining to participation and 2 other pertaining to compliance. Pertaining to participation is we test the bandwagon effect. Actually, is the larger number of ratifiers a factor that increases the likelihood of ratification of a given agreement? Is the closeness in institutional capacity a factor that increases the likelihood of ratifying an agreement? And does precision reduce the likelihood of ratifying an agreement? Regarding the compliance hypothesis, I'd like to test whether precision reduces or increases compliance, and whether having high institutional capacity increases compliance. So to test this empirically, I construct a vagueness index. The study is mainly concerned with environmental agreements that are interested in climate change, mainly the Vienna Convention, Montreal Protocol, UN Framework Convention on Climate Change, the Kyoto Protocol, and the Paris Agreement. And given these criteria, mainly whether we have numerical targets, how specific are the provisions of the agreement regarding monitoring, sanctions, incentives, and so on. And we construct an index for each agreement. Okay. So in the baseline specification, I test whether the bandwagon effect takes place, and actually it's found that this is a panel linear probability model. The higher the number of ratifiers, the higher the probability of ratifying the agreement, which actually proves that the bandwagon effect is present. And to see whether this bandwagon effect depends on the distribution of institutional capacity, I introduce the variable institutional difference. Okay, so we see whether the institutional difference of country I, how far it is from the top institutional difference of the countries already ratifying the agreement at a given year. So actually, large institutional differences are found to decrease the probability of ratifying the agreement, meaning that we would like to ratify agreements with countries that are closer to us in institutional capacity, meaning that the bandwagon effect actually occurs within countries in neighboring institutional capacity distribution. And finally, to see whether there is a trade-off between vagueness and depth. Actually, just note that vagueness here is country-specific and not agreement-specific. It measures the sum of total vagueness scores for all the agreements to which the country has ratified up to this point in time. So, in other way, this shows that a country that has previously ratified precise agreement is likely to ratify the agreement in the future. And this is good news. The more precise your previous agreement, the more precise your future ones will be. And this is good news. Regarding the compliance, actually we find the usual environmental Kuznets curve with CO2 emissions. Sorry, this is the food specification model. This is still the participation. We find the same results. And finally, whether to test the impact on compliance, we find the usual environmental Kuznets curve with GDP increasing emissions at a decreasing rate. Okay, so we find the usual environmental Kuznets curve. As for vagueness, this is the log of sum of vagueness. It's found to actually increase CO2 emissions, meaning that it reduces compliance. More vagueness, less compliance. And institutional capacity actually is found to decrease, yes. The higher your institutional capacity, the lower your emissions, the more compliance. This is to answer the idea of institutional capacity, reducing the cost of compliance. So to conclude, asymmetric and uncertain institutional capacity are very important to viewing environmental politics. In the recent years, vagueness could actually be attributed to the heterogeneity in institutional capacity of the emerging countries, of the new key players. This is actually our findings. There's some good news and bad news. The good news is, up until now, countries do not appear to shy away from agreements, from precise agreements, which gives a great opportunity for policymakers to draft precise agreements with precise commitments and still have everyone on board and still have high participation. We're still in the positive bandwagon effect. The bad news, however, if the environmental Cousins curve is persistent and inevitable, we would have in the future difficulties in environmental politics. To say this is the coal-fired plants in the year 2019. As you can see in gray, these are the closing plants. So in the US and the EU, this is not actually going to be a problem. They are not going to be of the top emitters, at least from this aspect. But you have rising powers in the Southeast Asia, Vietnam, Malaysia, Indonesia, South Africa. So you have new players that are coming to surface. And it gets worse when you see these are the planned and permitted plants, okay, up to 2020. And the number of rates, actually, the power is shifting to the east, as you can see. The problem with this is that emissions are shifting to the east. However, institutional capacities are not progressing as fast. So in the future, you would have negotiators, the key negotiators with low institutional capacity. The key recommendation would be then to, even if you cannot decrease the emissions now, at least enhance the institutional capacities so that you do not jeopardize future environmental negotiations. Thank you.
Thank you very much, Dina, for this very interesting presentation and for keeping up with the time. I just have 4 comments. Your paper is built on a very important assumption, and that is institutional capacity is private information. This is a very strong assumption, and I see that you have institutional capacity as one of your explanatory variables in the empirical model. So how did you measure it? If it's so much private information, how will you able to group countries according to institutional capacity? I also had a question, a comment on the fact that you don't have institutional capacity as an explanatory variable, but this was in the paper. I can see now that in the presentation you've added it. You need to provide an explanation for why the number of countries reach a certain threshold, for why when the number of countries reach a certain threshold, the incentive to join the agreement falls, and what is this threshold? It is interesting to examine how your model can explain participation in the Paris Agreement. Was it vague enough? Does institutional capacity explain participation? So the floor is yours.
Okay. Thank you, Abir, for the valuable comments. Actually, yes, there is a bit of a discrepancy. I totally agree with the theoretical model and the empirical part. However, my justification for this would be that institutional capacity being uncertain in our model is key in deriving the assumptions. And it's based on the idea that only the policymakers of country I would be aware of institutional capacity and the outcome of the applied policy. However, in the empirical model, what we use actually, we call it a proxy for institutional capacity. So even though it's uncertain, even though it's unknown, we need some proxy for it to assess its impact actually on the whole game, the whole outcome of the game. The threshold for, the threshold falls as, as a threshold is approached, the incentive to join is decreases. Actually, this was dropped in the presentation now. The idea of number of ratifiers squared, this is the question?
Yes.
Yes, but actually it's dropped in the new version of the model. It was not quite relevant to the analysis. But basically the idea would be that if we're mostly all on board, the probability of having newcomers is quite small because a few are out. That's the idea. The remaining ones are very few. Participation in Paris Agreement. Actually, this was a main motivation of the paper. However, Paris Agreement being quite recent, the data were insufficient to quite explain actually how vagueness affected participation in the Paris Agreement, given that data on institutional capacity are available, I think, starting 1996. So the pre and post agreement data were not quite sufficient to assess the impact of vagueness of the agreement. But hopefully this would be kept for future work.
Okay, thank you. You have two questions in the question box. Can you read them, please, and answer them?
For some reason, it wouldn't open. I don't know why. I can't open it. I'm sorry. I can read the chat, but I cannot access the Q&A.
Okay.
Abir, are these questions for Dina, or they were just not marked that they were answered from the previous paper?
I'm not sure. Shouldn't we have?
I think these were from Hoda Abu Bakr for the previous paper.
Okay, so these are for the previous paper.
Yeah, yeah.
Okay, and in the list of participants.
Shahir, do you want the floor?
Yes, I just have a very, I previously discussed the paper with Dina because we're working together at the faculty, so we had a lot of discussions on the paper, and it's very interesting. I just have one question on in terms of policy implications. So in this case, if we assume that African countries are going to include some environmental clauses in their African free continental free trade agreement, so in this case, they will tend to have a more generic agreement, given the fact that the quality of their institutions is rather bad.
Yeah, okay, I should answer. Okay, so actually the main implications of the model, if the institution qualities are skewed to the left, meaning that you have bad institutions but not quite bad, in that case you could still have precise agreements. However, if institutional qualities are let's say mediocre at the very low end of the distribution, then in that case the best that could be done is to have vague agreements to ensure higher participation. So actually it depends on that case, yes, of the key players. And what is implied here is that the institutional capacities of the key players is what matters.
Okay. Thank you. Thank you, Dina, very much. So we move to, if there are no further questions, I can see nobody's raising their hand. So we can move to the third presentation by Jonas Luckmann, Redistributing Water Rights Between the West Bank and Israel, More Than a Zero-Sum Game. Go ahead, Jonas.
Yeah, so thank you very much. I hope you hear me well. Thanks to the organizers of ERF for making this possible now as an online event, despite the crisis, and thanks for organizing this interesting session. Very happy to present here. We'll be moving now from global scale global agreements to one very specific one, and from empirical models to a simulation model. And I'm going to talk about water rights, as has been explained already, shared water aquifers between Israel and the West Bank, and the question whether it will actually beneficial or will it be more than a zero-sum game to shift water access in the region. And the work I'm going to present is co-authored by colleagues from the Humboldt University, from the Chair of International Agricultural Trade and Development, who are Khalid, Siddig, and Johannes Agbahey. So, looking in the situation or the case I'm going to present here is actually the mountainous aquifer, which you see here on the map on the right-hand side, is actually stretching below the West Bank. So the green line marks the West Bank and stretches into Israel, which is neighboring. Specifically, the replenishment or the recharge area is mostly below the West Bank. And as it is a shared water resource, of course, always the abstraction of one entity will have implications for the other one. So because of that, this is governed, the access to this aquifer is governed through this bilateral agreement, which is the Oslo Agreement of 1995, which is actually still the current agreement in place today, although it was only foreseen for an interim period until a final agreement is found to govern that aquifer. And here are the allowances according to that agreement. So as you see, Israel is allowed to extract about 480 million cubic meters annually, and Palestine on the West Bank 120. And there was also foreseen that there would be an additional quantity to be developed by the Palestinian side. However, if you look at the data from 2011, which is the base here of our study here, you actually see that Israel is using even more and Palestine less than its allowance even, and there was no further developments in terms of additional wells being drilled. And that is because the access to this aquifer is largely, is governed by the Joint Water Commission, and basically Israel has a veto right on development of new water projects in the region. So that often leads to demolishment and non-authorization of new wells. And even by now, the latest data of 2017, which I found, this does not have increased much. It's now like 109 million cubic meters. So a quite unbalanced distribution. It has been often criticized, this agreement. So the study I'm presenting, we look at making or giving more rights to the Palestinian side. Looking at their total water balances of the West Bank and Israel, we see that basically the West Bank, for the West Bank, it's the only domestic water source, this aquifer. And they import additional water from Israel, whereas Israel also has different water sources. So they also exploit the Jordan River, for example. And in the background, you see, for example, also the coastal aquifer, which is used by Israel. Then they do have desalination plants. Reclaimed water is used in agriculture and irrigation, and also brackish groundwater more to the south of the country is used also for irrigation. So there's a wider variety of water sources being used in Israel. And if you look at the water availability per capita, you see also there's quite a difference between those two entities. Although water is scarce in the region as a whole, the level of scarcity differs between those two. And because of that, and due to the geographical situation with the West Bank being landlocked and Israel having access to the sea for desalination, for example, the differences in economic development, with the agriculture sector being the largest water user in both entities, but having a larger share of the total GDP in the West Bank, the dependency on this groundwater resource actually differs considerably among those entities, and there's different level of severity of this water scarcity. So potentially there should be gains from reallocation of water resources or water rights. So we do analyze this using a so-called computable general equilibrium model. And this type of models, this class of models, they are capturing actually the interaction of all economic actors within an economy, such as household, the government, activities, or also firms who engage on commodity markets and factor markets. So basically households, they consume commodities, they provide their factors they own, as for example labor. In factor markets, they receive then wages. So here the arrows, they represent the monetary flows. And then activities or firms, they produce those commodities. So they sell commodities, receive income from them, and they pay the factors. Yeah? So they pay the labor. And the government charges taxes. The government also consumes. There's the rest of the world represented, imports and exports. So that's the basic principle of CGE models, which capture the economy as a whole in such a circular flow of money between the different agents. And then the model we are using here is called Stage W, is focused on the water sector specifically. So it includes different water resources, such as the groundwater from the aquifer we are talking about, but also seawater for desalination, and wastewater or sewage to be then used by specific water activities, such as desalination or purification of groundwater or reclamation of wastewater. And these activities then produce the commodities which can then be consumed by other users, such as the households as potable water, or activities such as agricultural activities using these water qualities for irrigation. Then we have also satellite accounts, because standard models capture only value, all the amounts in value terms. So now this allows us also to put quantity restrictions. And we have a wide set of taxation instruments. And then we use this model and apply it to these two entities, to the West Bank and Israel, using up-to-date databases for those two entities. Specifically, the water sector, which is of our interest here, we model in detail, and we have here the example of the West Bank in quantity terms again. So we have the domestic water source and the imports. So that's the total supply, but then we also capture the losses, because these are quite significant in the West Bank. And that's all non-revenue water, which can be leakage from the system or just non-charged water, theft, and all these contribute to about even 30% in the domestic sector of the water is not charged. In terms of pricing, what we know from the data is the provision cost of water from the domestic sources, and this here is now calculated based on 1 cubic meter being supplied to the final user, so it includes all these losses already. And the imports, so what is charged to the Israeli by the Israeli water supplier. And then, as we know, also the final user price, and there's a difference. This is kind of a black box, but we model it with this different taxation instrument, being an import subsidy to balance out this price difference, then the reduction of the price until it reaches the user, and then there's also some differentiation between other activities or productive activities such as agriculture and household consumers. So all this is also captured within the model. And we use now this model. As I mentioned, we actually run 2 scenarios in the paper. You will see both scenarios and the results of both. Here I will focus only on the second one due to time. And this is that we move, we say the aquifer, the mountainous aquifer, is now shared 50-50. So each entity should get 340 million cubic meters. And that would mean a huge increase for the Palestinian side, so for the West Bank, and a reduction of the same amount to Israel. So that should not be like a political statement or a recommendation, this quantity, but it's just for demonstrative purposes here. So it's of course up to the policy makers to find an agreement, but we suggest our model could be very useful to substantiate these with some figures and see what actually the consequences are. And let's look at that. So what would actually now happen in terms of the West Bank's water supply and use? And you see, of course, that would be for the West Bank a huge increase, almost tripling the water supply. And the imports we leave untouched here for the simulation purposes. These are long-term agreements. So these do not change here, but endogenously the model then determines how this additional water is distributed through the different sectors, and also for the households. You see, especially the households, they increase their consumption much. And for Israel, we have here the same. So what are the implications on the Israeli water supply and use? And we see, yeah, for Israeli side, this is just a reduction of 24% of the total freshwater supply from wells and springs. And in the long run, in the paper, we also have a short run scenario where we keep the desalination capacity fixed, but in the long run, Israel could expand desalination capacity, and we also account for the cost of additional investments required. And this, as you see, would almost counterbalance the loss, so to say, from the transfers. So the total balance is basically almost unchanged. Brackish water reclamation is not changing much, and because the total loss is captured by the additional desalination, on the user side there's also not much adjustment required. Of course, the desalination is more costly than pumping the water from the mountain aquifer, so there are some costs to the Israeli economy, and we'll see about that, but there's not much adjustment required. So what does it mean now for the economies of those two entities? And we see with this additional water, agriculture sector output would grow, because here water is a relatively high percentage in the total cost share of production. Also service sector would actually expand, but that is mainly driven by this one water activity, which is now producing much more water for final consumers. And but there's also the industry, which has a very low cost share actually of water in the West Bank expanding. This is more due to indirect effects, because agriculture is now consuming also more industrial inputs. Households which receive higher income from agriculture, they do consume additional goods now. So also the industry sector is expanding. On the Israeli side, we have actually very small losses to agriculture and services, and also a slight increase in the industry output, as this has the lowest share in cost of water and gets then benefits a little bit from not having to face higher water prices. What does it mean on the macroeconomic effects for those both entities? So the light blue here is the West Bank, and we there experience a much increased domestic production, more than $400 million worth of additional domestic production. Also Israel expanding slightly here, because also desalination requires then again intermediate inputs and so on. For household consumption, positive for the West Bank, negative for Israel. This is due to households or products getting more expensive in Israel, and the saving rate in Israel is increasing. Both entities engage more in trade. Imports and exports are rising, so there's also more exchange between them, more specialization and more trade between those two countries. And most importantly, the GDP. So we see here for the West Bank an increase of $130 million and a decrease of 25 million for Israel. So that's basically the economic costs to Israel for redistributing or giving additional water rights to the West Bank. And when we relate this to the total economy of these two countries, we find that the West Bank's economy would grow by 1.65% additionally through that transfer, and Israel would only lose 0.01% of its GDP because the economy as a whole is much larger. So the answer is no, it's not a zero-sum game. Yeah, so there's actually region-wide, we still benefit by more than 100 million US dollars annually from such a transfer. And this is due to the lower substitution possibilities on the West Bank side for this groundwater, and the higher relative dependence on that mountain aquifer, because there are no other sources the West Bank could exploit. And we did not consider here the additional effects or gains which would come through peace building aspects of this, right? Because some of the current conflict is caused by this distribution of water rights as it is right now. And maybe a more fair distribution would lead to more peaceful relationship, and then could save also on the Israeli side costs which are now there for due to the situation of conflict. And there's also low political costs for the Israeli side because they do have the capacity to increase desalination, so they could compensate, for example, farmers who fear that they lose then the possibility to farm the land at a low cost. We saw $25 million US a year. That is much lower than costs of this conflict, which is right now there. So in general, one can say that this kind of model possibly could be used to substantiate the political negotiation process more and help thereby to come to a final agreement. Hopefully this process will be still ongoing at some point again. So advantages are that we also include indirect effects from such a reallocation. We consider that because we have, for example, the factor markets in that when the agriculture sector expands, there is higher demand for labor and higher wages being paid, and then households who earn more, they can consume again more. All these second round effects are considered. And the approach could be, of course, also expanded to other water resources, other shared water resources, such as the Jordan River, which is currently only used by the Israeli side. Okay, that's already it from my side. Thank you very much for your attention. If you're interested in more details, please have a look in the paper. So there I have more scenarios and more results, and I'm looking forward to your comments or questions.
Thank you very much, Jonas, for this very interesting presentation. I have a few comments. You've mentioned in the paper that in Israel, different users of water pay different prices. So what about the Palestinian part? Do they pay the same prices or also different prices? I think it will be interesting to see what happens if all users pay the same price of water, and where the price is the price that balances demand and supply. Why changes in welfare were not examined in your paper? How did you assess whether consumers are better off or worse off in the paper? You've mentioned also in the paper that the cost of desalination leads to lower income of a household if it's financed through higher taxes. But desalination could also be financed from aid received by Israel. I don't think this is a problem they will face, how to finance this. Plus, the cost of desalination is going down because they are using renewable energy in the process now. Water scarcity would no doubt affect incentives to invest, and thus the use of a static model versus a dynamic model overlooks some important implications. So, your comments?
Yeah, thank you so much. Very, very relevant points here, of course. And yes, some of this I could not address here due to time. Yeah, the first issue you mentioned, the differentiation in prices among users, which is a reality in Israel, where the agriculture sector pays lower fees than the industry sector and the domestic sector even higher. And I looked at this actually, and the price reform, I have a paper on that on the Israeli side. So I applied this model to Israel and did exactly this, what you suggested, to see what happens if all users pay the same price. And there are, of course, welfare gains due to that, removing that kind of distortion, because there's kind of a subsidy scheme going on in Israel, subsidizing agriculture water prices because the supply costs are higher. And to some extent, we also have that in the West Bank here, where we have higher supply price than the prices are paid by the final users, which, however, is mainly driven by this high share of non-revenue water. So that is also one issue one could investigate further. It was not the scope of this paper here. The benefits of actually improving the distribution network to avoid leaking, and also the governance of the water sector to so make sure that all the users also are paying their water bills. Yeah, so that's an issue that could be addressed on the Palestinian side. The welfare, yes, that is also an important implication, and we did not present that in the paper so far. The model, of course, is capable also to see the changes in welfare, for example, using the equivalent variation. So how much money would single households be willing to spend in order to be at the same welfare level than in the base situation. And this, why we did not present that, is connected to the way we model here the water pricing, because now for the Palestinian side, for example, a lot of additional water is coming in. Right? We've seen it's almost tripling, which is a huge shock actually to the economy of Palestine or the West Bank. And in order to make use of this water, the water price would be lowered. Because this is the assumption of this type of model, all markets are in balance. So now the supply is increasing. That needs then a negative or depression of the price in order to find a new market equilibrium. And due to this, that situation which I showed you was the water price here scheme, where now the prices charged to the final consumers would be lowered. That leads to additional subsidies, so to say, which need to be covered then somehow by the government. And this again can only do that when it raises a tax elsewhere, when it increases income elsewhere. So we model that with an increase in the household tax. And that again has negative implications for some households, because they are now paying higher taxes and they may not benefit so much from the lower water prices. And I'm still thinking of finding maybe other ways to model that in a better way. And that's why I so far did not present the welfare results. But that's a very relevant point here. And in that context, you also mentioned the issue of financing desalination. I was not thinking of putting desalination in the West Bank side because of the difficulty to access the sea. But for the Israeli side, that is an option. And and the issue of having that financed by foreign donors, that's of course, or any additional water to be financed, also maybe this could be financed through foreign donors. but then it is like a gift to the economy, and that, of course, in any case, will lead to positive welfare implications. So that's I was trying to, in my approach, have everything being financed through the respective economy itself. So if there's additional need for investment, then this should be also financed through the taxes charged in the economy. And that brings me also to your last point of a static versus a dynamic model. And that's also, of course, an important point. In case, for example, we would run a scenario where then maybe additional water capacity is exploited, or desalination capacity is built and financed through the government, and there's a change in the government savings to do that. Maybe the government takes up additional loans. Then we would also, with a static model, lose some of the welfare implications, because these loans will need to be paid back in later periods, which we don't capture in a static model. So for such kind of simulation would be useful to have a dynamic model which captures then several periods, one after another. Or if it's important to track the development of the capital accumulation over time, or the other factors that the labor force is growing over time. So what our model does is, as a static model, putting a snapshot of the economy of 1 year, and says, what if in this year we had more water, in this case in the West Bank, and therefore less water in Israel, without any growth of labor force or any other growth pattern in terms of also technical development and so on. So it's not really a forecast. We try to keep all the welfare effects within that 1 year by not allowing the government to spend more than it receives in income, to take care over that potential disadvantage. So I think for this kind of analysis, a static model is appropriate. Maybe I finish with that. And I hope I have addressed most of your comments. Please correct me if there's something still you are not sure about.
Thank you very much. Thank you very much. We have questions here for you. Can you read the questions, please?
Yep, and I need to go out. Okay, sorry. I see. It says, won a conference paper after finishing all the sessions. Not really a question I can answer, but I think you can download it from the conference webpage, right? Otherwise, I can. But isn't there in the chat the link? Yes, somebody put in the Zoom chat the link to my paper, so you can get it from there. And I do see a hand again by Shahir Tsaki, but yeah.
Thank you, Jonas, for your. Yes, thank you, Abi. Thank you, Jonas. I just have one clarification question and two suggestions. So the clarification question, I didn't really get how you model water. In your model, do we assume that different sources of water are perfect or imperfect substitutes? Is it, how do you model the elasticity of substitution between different types of water? And especially if we assume that water is imported, is it an Armington function that you adopt between Palestinian and Israeli water? That's the clarification question. And then I think for the two suggestions, you partially addressed them when you answered Abir, but I think it would be very important to model the cost of this whole process, because even if, for instance, if you have a closure of your model where your fiscal deficit will have to remain constant, then in this case, this means that you will have to reallocate your public spending or if it's exogenous, then it will be reflected on receipts. So I think this whole process will change a bit how how you really tackle the cost of water in your model. And second, I think also when you address, I totally agree with you that static models in this case can be informative and relevant, but at the same time, I think whenever you think of extending the model and do it more of a dynamic, sequential dynamic model, for instance, it will be very important to show how TFP, the evolution of TFP in your dynamic model is affected by water abundancy, because it's vital for the evolution of the economy as a whole. So those are my comments. Thank you.
Yeah, great. Thank you very much. These are also very useful comments. Regarding your question on how we modeled the different qualities of water, true, I did not present that due to time, but in the paper you can see we allow for substitution between different water qualities, which only holds for the Israeli side. However, as I've shown, there's only one quality on the Palestinian side of the West Bank, which is then the potable water. And in the Israeli side, these other qualities, which are reclaimed wastewater and brackish water, can be used by irrigation, by farmers, by some farming activities, because there are also restrictions for using reclaimed wastewater, and there are then substitution elasticities put in place. From my head, I actually don't recall now which one, how high they are, not that high, because it depends a lot on the type of crop. And for potable water being produced from desalination and from pumping and purification of groundwater, that we consider as one homogeneous commodity. So yeah, that's two activities basically producing the same commodity. So it's a perfect substitute. And that also holds for the West Bank side, for the water being imported through Israel or produced by the water activity in the West Bank. So that's a perfect substitute. And yes, regarding the sequential dynamic suggestion, yeah, I mean, generally, yes, I'm very interested in also moving dynamic and building, improving the model further. And you're right, the effective productivity would change because now then one can imagine that there's more irrigated agriculture and then higher yields on a hectare. What I was trying to do is to capture that through having two sectors, one being non-irrigated, rain-fed agriculture, and one being irrigated. That's not in this version yet, but working on that, so that there's a shift from the rain-fed to the irrigated sector. Yes, so thanks again, and still work in progress, yes.
Thank you very much, Jonas, and thank you very much, Shahir, for your questions. So let's move to the fourth and last paper by Insaf Guedidi, Carbon Dioxide Emissions, Environmental Provisions, and Global Value Change in the Middle East and North Africa in a Global Context.
Okay, thank you very much.
Insaf.
Okay, I'll start?
Yes.
Okay. Thank you all for your presentations, and I would like to thank the organizer for organizing such session under especially those conditions. So the paper is CO2 emissions, environmental provisions, and global value chains. So in the context of the MENA region, as recently the rise of global value chains is considered one of the most important features, especially in terms of economic globalization. And it is explained in many ways, for example, fragmentation of production, trade in tasks, global production networks, etc., where the production process is fragmented all over the world, is sliced up, and then the product is produced internationally. Why we are interested in global value chains? Because in here, for example, when we trade under global value chains, it means we are using more international freight transport. And here there is an indication that air pollution coming from international freight transport could increase by 1,060% by 2050, which is like a huge thing. And for example, for the trade agreements, NAFTA, so those are the motivations actually. For the NAFTA agreements, after 5 years, it has been proven that signing the NAFTA agreements reduces emissions of pollutants by 2/3 in the United States for the manufacturing sectors. And here, the CO2 emissions were shifted from developed countries to developing countries. So why is this? Because there is a positive aspects of global value chains, like for example, creating more opportunities, job opportunities, or for example, another example is giving local firms the opportunity to use their comparative advantage to do what they can do the best. There is also other negative aspects, like for example, creating more pollutant havens. So in here, the pollutant havens in general, they are in the developing countries. That's why probably multinationals, they shift and relocate towards those countries. So the research question would be, what is the impact of global value chains in terms of forward and backward participation on carbon emissions in the presence of regional trade agreements with environmental provisions? So in here, it's like to link three main ideas: global value chains, CO2 emissions or pollutions, and trade agreements with environmental provisions. So in here, there's a representation of the evolution of the number of trade agreements, and they are classified by 3 sections: with environmental provisions legally enforceable, without environmental provisions, and with environmental provisions not legally enforceable. So in here, for example, after 2000, we noticed there is an increase in the number of, we sign more trade agreements with environmental provisions. And also, since we can notice probably in 2015, for example, the number of environmental provisions legally enforceable, the trade agreements with environmental provisions legally enforceable, it's like slightly higher than the ones not legally enforceable, which is something very noticeable. Here about the literature. So here, the first section, there is the relationship between pollution and trade agreements. We can mention the paper of Serwin Chan 2017 and Yao et al 2019. And the other authors, they have evaluated the impact of RTAs with and without environmental provisions on pollution. And for global value chain participation and pollution, we have what the World Bank emphasized on, which is international trade in intermediate products, rises domestic CO2 emissions in developing countries. And also global value chains are affected by policies related to the investment, to vertical specialization, and also to environmental laws, whether they are implemented or not, whether they are weak or not, let's say. And then there is another point, which is, for example, China's trade openings and foreign direct investment increase air pollution. So here we may think about what is the impact of global value chains, and also it's probably important to think about the forward linkages and backward linkages of a country in global value chain, and I will explain the difference of both later on. So this paper, first it examines the empirical relation between trade, and the environment in the MENA region. Data are between 1990 and 2015. Also, it analyzes the impact of RTAs with and without environmental provisions on carbon emissions. And there is another specification. There is also for the environmental, the existence of the environmental provisions. We analyze whether it is important that they are legally enforceable or not. And then it contributes to understanding to which extent integration in global value chains forward and backward and signing more RTAs with provisions relating to the environment could shape the environmental sustainability in the MENA region. So we take the MENA region as the emitter of the COD emissions. So here, the classification of the gross exports. In this step, we will explain the difference between forward, the global value chain participation, and backward. So we mean by forward, so gross exports are divided into the domestic value added and the foreign value added. The foreign value added is the value added that a country imports in order to export again to a third party. So here, like imports, that will be exported. So it is a backward linkage. It means the downstream activities. And then we have the other classification, the domestic value added. They are divided into exported as whether to export final goods or to export intermediates that will be directly consumed in the partner country, or exported as intermediates that will be returned to the same country. It means re-imports. The forward linkage is the exported as intermediates that will be further re-exported to a third country. So to explain basically global value chains is when the product crosses the border 2 times. It means there is at minimum 3 countries involved in the value chain of the product processing. And here, how it is calculated. So we have the participation index of the global value chain. It is the sum of the forward linkage and the backward linkage. Forward global value chain participation is the indirect value added divided by gross exports times 10. It's a percentage. And then the backward global value chain, it is the foreign value added divided by gross exports. So it's the same, just to change the first millimeter. And here we have the data. So COD emissions, number of RTAs with environmental provisions, without environmental provisions. For the environmental provisions, they are whether legally enforceable or not legally enforceable. And we have the index of forward participation and backward participation. So the COD emissions is the bilateral relationship from the MENA country, which is the emitter of the COD, toward the consumer of the COD emissions, of the receiver of the pollution. So about the model, so we have the period covered is 1990 to 2015. We implement the gravity model. So this time it's not implemented from a international trade perspective, but rather it's from environmental perspective. We have other examples of other papers like Inyawi et al., Baghdadi et al., Duarte et al. They have all implemented the gravity model, taking the dependent variable. Sometimes it's the COD emissions. And the second example is the water exports. The region is 19 MENA countries originating pollution, and we implement the PPML estimation. So this is the representation of the carbon emissions. Here we have all the related gravity variables like the GDP, the distance, contiguity, language, colony, etc. And then we have the number of RTAs with the 3 specifications, and we have the forward and backward linkage, and then the interaction to see if, for example, we are linked in a forward with forward participation. With the existence of a specific type of an agreement, what is this impact on the COD emissions? So here the first table of the estimation. So this we have the impact of the number of RTAs with legally enforceable. So we see it is a negative and significant for the number of RTAs not legally enforceable and not legally enforceable and without provisions at all, environmental provisions. So there is insignificant. So here we can say that the enforceability of the environmental laws is important to reduce emissions in the MENA region. And here we have the interaction terms. So here we say like for forward participation, when the MENA region is linked to global value chains in terms of forward participation, the legal enforceability of the agreements is important, and it contributes to the decrease in the COD emissions. But it's not the same when those environmental provisions are not legally enforceable. It's just the opposite. And for the third and last table, we have the backward participation. In here, we can say that for the MENA country, the existence of the environmental provision in itself is important to reduce emissions. However, when it does not legally enforceable, it's not compared to the first table when it's forward when it is forward participation. So here are the main results. We have the enforceability of RTAs, which contains environmental laws, decreases pollution. So those results are not far away from what all show, where RTAs without environmental provisions actually harm air pollution or doesn't have an effect, as in our case. For low-income countries suffer from pollution even after signing more FTAs. It means even after signing the FTA, it's not with environmental, with non-enforceable or lenient environmental standards, it will not reduce pollution. Sorry. So the enforceability and of the provisions is very important, especially for the low-income countries. And here we can say that upstream tasks in global value chains does not contribute to environmental deterioration in the MENA. And exporting foreign value added, it means the downstream activities increases COD emissions in the MENA. And this is probably explained by the fact that multinational firms headquartered in developing countries perform their pollutant activities in countries with relatively weak environmental laws. So here we come back to what we call the existence of the pollutant heavens. To conclude, RTAs with legally enforceable environmental provisions reduce carbon emissions, and participation of MENA countries in backward global value chain rises actually environmental degradation. And this study in general helps to identify to which extent we need to negotiate environmental policies in the MENA region, and to make sure that those environmental laws are not lenient, they are respected, and we do it. And we are respecting actually every provision in each agreement. I think that's it. Thank you.
Thank you very much, Insaf, for this very interesting presentation. I had several comments, but you've answered them in the presentation. They were not clear in the paper, but you've answered them in the presentation. It's just that you need to rewrite the empirical results so that they are clearer to the reader. You also need to, in the literature review, to discuss the channels to which trade affects the environment negatively or positively. A discussion of the nature of environmental provisions in regional trade agreement would be helpful. What is the nature of these provisions? You've the role of institutions was neglected, although the effectiveness of environmental provisions in regional agreements hinges on the quality of institutions that enforce these provisions. Finally, how was the enforceability of environmental provisions assessed?
Okay, so I think I have answered most of the previous comments, but I will focus on the last one: how enforceability, how we assess enforceability. Actually, it's not like the assessment of the enforceability. I took the variable as the number of trade agreements with all with three types of classification. So the first one is legally enforceable. So it's not like the enforceability in itself, but number of agreements with enforceable provisions. It's a dummy variable actually, and it is taken from okay, sorry, I need to have to go back to, because the data is bilateral, and in here we have it's from the Mario Large Regional Trade Agreements database, where we have the trade agreements by bilateral relationship in two countries, and then we have all types of the agreements and whether they are with different provisions, and then if those provisions are enforceable or not. There's even other related type of provisions, like provisions related to intellectual property rights, investment, etc. Okay, so I don't know if I have answered the last question.
Okay, thank you very much. Can you see the question and answer if you have questions or not? I don't think there are questions from the audience. Shahir, you have a question?
Yes.
Okay, go ahead.
Thank you, Abir. Glad to see you, Insaf, over Zoom, and please send my regards to Leila. Thank you for the very interesting presentation. I just have a couple of questions and suggestions as well. My first question, I was wondering why you implemented a PPML estimation. Do you have a lot of zeros in your dependent variables, yes? Because if not, I think you might also want to try running a normal, panel fixed effects if you don't have a lot of zeros in your dependent variable. That's one. And two, I think also it would be important to incorporate among your controls the quality of institutions, because I assume that the quality of institutions will first affect CO2 emissions, whether we have stringent laws that are really enforced, and hence they will like oblige firms to adopt clean technologies, and this is likely to reduce CO2 emissions. So the quality of institutions, whether it will be measured by some indicators from the World Governance Indicators or doing business data sets, I mean, any kind of the quality of economic or political institutions, I think will be fundamental in the analysis. Third, it's more of a clarification question. I didn't really get how you converted your CO2 emissions into a bilateral variable. Is it an additive variable? So you add the emissions of the exporter and the importer, or the two signatories, I mean, or it's multiplicative. So you multiply or you take an average. I didn't really get it. Then another comment, I think, I don't know if it's doable or not in your data set. It will be also important to distinguish the backward and forward linkages take place in which sectors, meaning that do they take place in polluting sectors like oil industries or chemicals that are likely to emit much more CO2 emissions than products that are intensive in high technology or electronic products or and so on. So is it possible in your data set to distinguish between the types of, I would say, global value chain linkages that take place in traditional sectors like chemicals and oil versus non-traditional sectors that are intensive in high technology? And this perhaps can explain why for instance, we have more global value chains in developing countries in polluting industries, because they have backward and forward linkages in such polluting sectors. Then I saw that in one of your regressions that the backward and forward linkages were not significant. So perhaps I was wondering whether you tested if there is a multicollinearity between the two variables, meaning that countries that are probably have a lot of backward linkages, they might also have a lot of forward linkages, but perhaps it's not the case. I don't know whether you tested for this. And finally, I think in the regressions where you introduce your interaction variables, it's also important to introduce the two levels, meaning that if you introduce, for instance, the interaction between RTAs and backward linkage, so you have also to introduce the two variables, each one on its own. And that's it. Thank you.
Okay, thank you. So I'll start by the first question, why PPML? Actually, there is not a lot of zeros in the database, since even the data frame is with a smaller set of countries. We've took only 19 MENA countries as the emitter of the global value chains. But I could like explain this, like even the existence of the zero is important. It's like to say there is no emission or no carbon emission to this specific country, or probably participating in activities, but they are not contributing to the pollution. So that's why. And for the quality of institutions, the variables related to quality institutions, yes, I think it's a really good suggestion. I'll take it as plus in the paper. And also for COD emissions, how they are bilateral. Actually, they are from EURA database. So our COD emissions related to trade. It means related to exporting and importing goods only. So, and they are bilateral in the database, and they are available for many countries compared to other databases in the TIVA database, for example, or the World Bank, etc. And also to distinguish between forward and backward in terms of industries. Yes, I think it's possible to calculate it, and it will be an added value, as we know that tangible activities in few sectors is not like the intangible ones, for example, research and development, and its impact on the pollution is not the same like manufacturing or assembly and its impact on pollution. So I'll take this as an added value. For two levels, so I will check on that. I will take it also, and I will work with this suggestion as well. Thank you very much.
Okay, thank you, Insaf. I can see nobody else has raised their hands. So if nobody else has a question, I would like to thank the panelists for their very interesting presentations and for keeping up with the time. And I thank the audience, especially Shahir, for his questions.